Hi, so we are going to go through a STEM lesson, one that you could actually do with students if you had, all you really need is some measuring tape, a piece of paper, and then a book. That's it. So, and a way to record. I'll talk about that once I get into it. So I'm using Classpad.net. This is an activity that was adapted from Fostering STEM Education with Casio Technology. So I've converted most of it into a Classpad.net activity. The link to that is below. And Classpad.net, I feel like a broken record, but it's basically this amazing free dynamic math software where you can pretty much do anything. I'm sharing the activity. It's completely free to use. You don't have to have an account, but if you like it, I really highly recommend you create your own account, because then you can save things, you can modify, you can create your own lesson. So easy to do, just push a button. The website's just Classpad.net. I'm going to go into the activity, so it's just the URL link, put it in my browser, and there I am. And so basically this is an activity that is STEM, so science, technology, engineering, math. And this is related to falling objects. So we've got drag and lift and free fall and weight. So some definitions up here at the beginning. And then it is something that they could do in person. So a great, pretty easy thing. So it shows you the materials you need. So you need a book, a piece of paper, a stopwatch, or a camera video. I would suggest, especially with everyone having phones, that you use a video, because then you can slow down and rewind. So you're going to have a measuring tape up against the wall up to 6 feet high, and someone's going to be dropping the objects from the height 6 feet, and then you're supposed to record the time as that object drops, so the time and the height. And so a video basically facing the tool that you're measuring and watching the object fall is probably the best bet, because then you can rewind and record all the times. I would recommend at least 3 people, someone dropping it, someone recording, someone writing down the times and heights. So here's how you do it. You drop it, and so first you drop the book, which is obviously going to fall faster than the others. Then you drop the paper, but you drop the paper several times. First you drop it just as it is, and then you fold it in half, drop it again, record, then you fold that half in half, and you continue to fold to like 4 or 5 folds. It kind of depends how big the paper was to start with, how many folds you're going to be able to do. But then what you're doing, if you do the experiment yourself, you're going to be recording in this table, right? So you're going to record your times, you're going to record how high the book was when it started, and then as it fell, where the heights were at different times. If you're not going to do it yourself, there is sample data provided. So you'll see there's a lot of times, and the times are recorded in minutes. And so there's a lot of times here. It's less than 2 minutes, so the time goes really fast, which is why I recommend a video. And here's the book. And so you'll notice if we just look at the data, the book clearly fell the fastest for the most part, but then look over here, the more folds we have, the faster it falls. And so that's sort of what the discovery here is. Because if you notice, the paper, not folded at all, took a really long time to fall. And so what's making that happen? If gravity's the same, what's making it go slower? So you got your air resistance. And so record or use sample data. And so then once you have either your own data or the sample data, you're just going to make scatter plots for each one of these. And that's really easy to do in Classpad. We want each one of them to be based on time. So we're going to select time and then books, and we're going to go to graph and scatter plot. And so what ends up happening is you will see a scatter plot. And so it's a typical, what you'd expect a fall to look like, but maybe students don't in this. It starts off kind of slowly falling, but then as you go along, it goes faster, right? Because gravity and resistance, all that stuff's kicking in. So now let's plot the other ones. And what will happen is you'll get a different scatter plot for each object, right? So here's the paper. So notice that the paper had a very different type of fall because of maybe weight and resistance and all that type of stuff. So then let's compare the paper as so I'm doing paper, and this time I want 1 fold and a scatter plot. And so we're just going to make all of them. And then I want 2 folds and kind of keep track over here. You'll notice that the scatter plots are telling you what color each one is and where you are in the thing. So I still have 3 more to do. But again, notice how fast it is to do this. So I am on 3 folds. And then we've got 4 folds and 5 folds. So let's 4 folds and finally 5 folds. And scatter plot. All right, so here's all my graphs. And oh, I obviously have a point plotted wrong there, so we'll have to go back and check which one that is. That's in the 5 fold, so there must be a point that I didn't record correctly. Or did I forget to record the 5 folds? There we go. Let's try. 5 folds is kind of strange. Let's try it again. 1 and oh, yeah, so there is one point up there that's let's get rid of that last one because we don't need it. There we go. All right, so now what they're going to do is you can kind of see what each color is. And so one of the first things they're asked is, okay, so what's happening? So the book was in blue, so that's here. And if you notice, the folded 5th paper is almost exactly on top of the blue. So that's interesting, right? Because it's a piece of paper, has a different weight, obviously. Why is it almost falling in the same path as the book? So it may have nothing to do with weight, but more about to do with, you know, area. And that's sort of where we're going with this. And so this paper that had a lot of area and felt less, it had a lot more friction, right? Air is more resistant to something that's light. So interesting things that they're going to explore. They're asked some questions. They're going to answer them here. And then one thing that they're asked to do, and I'm just going to show you how you can do that, is to kind of zoom in and get a closer look at the graphs. And you'll see that they start off curved, but then near the end, it's almost as if they're in a line. And we can zoom in closer and closer. What does that mean now if they're falling almost linearly here as they're going along? And if you want to see the graphs separate, you can pull them out. This is a cool feature of Classpad. You can pull them out by clicking. See how there's tabs down here at the bottom? You can click on the tabs. It's a little slow because I zoomed in. And pull the tabs out and separate the graphs. There we go. If I want to just say I wanted to just look at that one paper by itself, I can now kind of have a better feel for that graph. So different ways to look at it, and basically you're trying to understand that area impacts how fast something falls. So have fun exploring with this. Pretty easy to make all the graphs and then really get into the comparison and analysis.